And next, my favorite kind of story in life is the kind that reminds us that we are nowhere near as close to as smart as we think we are. And boy, does this next one do exactly that. You know that golden telescope we humans built? It's taking some mind-blowing pictures of space right now. Well, it turns out it's so powerful, it might have just shattered our understanding of the universe. We've all heard about how the new James Webb Telescope is kind of like a time machine because it can look back to the early formation of the universe. And it's been doing just that. It has taken pictures of 6 galaxies that are some of the oldest that we've seen, but they're a little hazy, and there's a lot going on in these images. Bear with us. For one, when you're looking at these things, they're supposed to be from the beginning of time as we know it, and they're not supposed to be all that well formed. Well, guess what? These are looking a lot bigger and a lot more developed than we thought. And why does that matter? Well, for one thing, it could pretty much rewrite a whole bunch of astrophysics textbooks. So, of course, we called up the legendary theoretical physicist Michio Kaku. He's the futurist who always has me dreaming of the cosmos and the author of a bunch of books that might need to be tweaked now if it turns out that the universe is older than we think. Hey, Professor, I'm thinking of some of my favorites, the God equation, physics of the future, future of humanity. Most of them say the universe is about 13 billion years old. What if it's not?
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang, that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only 500 million years old. Something is wrong. We may have to revise our theory of the creation of the universe.
And so we're possibly looking at a universe that's much older than we think it is, and we're also possibly looking at maybe this is an optical illusion. Are those the 2 options here?
That's right. Some people say it's an optical illusion. You see, according to Einstein, gravity can act like glass. The glass, of course, you can make a magnifying glass. With gravity, you too can bend space and time to create a gravity magnifying lens. So you think that these galaxies are huge when they're actually baby galaxies. Now, I personally think that the solution to the problem is these are not baby galaxies at all. They're actually monstrous black holes. Black holes that formed after the instant of creation. That's baffling scientists because they don't fit in the normal sequence of the birth of a galaxy. So I personally think that we're actually looking at monster black holes where perhaps new laws of physics are emerging. And again, if you can figure all this out, there could be a Nobel Prize waiting for you.
I'm sorry, you're saying that these galaxies, these 6 galaxies that look kind of like galaxies are actually black holes?
Yeah, that's one theory, because we think that at the center of our own Milky Way galaxy, there is a raging black hole that is 2 to 3 million times more massive than our sun. In fact, we now believe that at the center of almost every galaxy in the universe, there's a monstrous black hole that could be millions to billions of times more massive than our own sun.
If that's the case, then you're going to have to rewrite all of your books, and I think I have 2 of them with your signature on them, so I'm going to need you to re-sign and send me some new ones when you update those. Professor, since we have you, I'd also love to ask you about this discovery a lot closer to us here on Earth. It's another thing that I think you know a lot more about. Apparently, we just discovered that there's a 5th layer of our planet deep inside of Earth's core. What kind of knowledge do you think that could potentially unlock?
Well, you know, when you see the tragedy in Turkey and Syria, you ask yourself a simple question. Why don't we know what's underneath our feet? We've been to the moon, we've been to Mars, our probes have gone past Jupiter. How come we don't know what's at the center of the Earth? Well, here is a clue. Think of a sonogram. A sonogram shoots vibrations into the womb of a pregnant woman. The vibrations then create echoes that can be analyzed to create a picture of the unborn child. Well, we can now think about sonogramming the Earth. An earthquake generates all sorts of vibrations that echo, ricochet inside the Earth, allowing us to recreate an image of the center of the Earth. And we find some enormously interesting things. We find, for example, that the core of the Earth spins, but the crust of the Earth can spin in the opposite direction. So these layers underneath our own feet can actually rotate in opposite directions. And we used to think there were 4 layers, like the crust and the mantle, 4 layers inside the Earth. Recently, we picked up evidence of a fifth layer at the very center of the Earth. So we're now basically sonogramming the Earth. And maybe, just maybe one day, we'll be able to use artificial intelligence and supercomputers to tease apart these echoes so that we can get earthquake prediction. We're not there yet, but think about it. We could save the lives of thousands of people if we could somehow take these echoes, run them through a computer, create a map of the inside of the Earth, and predict when the next earthquake would hit. I think the people of California would really like that day when we can do earthquake prediction.
I'm sitting here in LA and thinking exactly that. It sounds like you're saying that we take earthquakes that are happening right now, almost use them like ultrasounds, and all we need to do is to just have the technology to capture the image from that ultrasound to really know what's in the Earth and how to predict earthquakes in the future. Is that right?
That's right. And these echoes of earthquake vibrations, we used to think they were nonsense. They're so complicated. But with supercomputers and artificial intelligence, one day I think we'll decipher all these echoes and be able to calculate the tension on the San Andreas Fault and many of the other fault lines and get earthquake prediction. It's not out of the question. We can't do it yet. But I think with supercomputers and artificial intelligence, we may be able to decipher the echoes inside the Earth, giving us a snapshot, a sonogram of the Earth itself.
Professor, always a pleasure to speak with you. I know you have a lot of work rewriting some of your amazing books as we speak. Thanks so very much for joining us.
My pleasure. Anytime.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.